Hello everyone. I'm going to continue talking about the limits of rational functions, okay? So here we have a rational function. Okay. So it's 3x minus 2 divided by the square root of 2x squared plus 1 as x approaches infinity and as x approaches minus infinity. Now, you can see that both is going to be an existing limit here that's not going to be 0 because the top power, the largest power in the numerator is 1, and the largest power in the denominator is the square root of x squared. So it's actually x, okay? So you have x at the top and you have x at the bottom. But you can't just divide everything by x because then for example, if you divide everything by x, this x is going to be out of the root. So you got a problem here, you see. X approaches infinity and x approaches minus infinity. So what do? Okay, you want to divide everything by x. When you divide it by as x approaches infinity, for the denominator, you want to divide by the square root of x squared. Okay? Now, as x approaches minus infinity, you think, okay, so you can just have... it's the same thing, right? Because you're just going to take the positive root, because remember, since the index right here at this point is even, it's 2. So you can have plus or minus square root of x squared plus of x squared. But we're just going to consider the positive one here. Okay? This is a tried and true method. You're not going to consider the negative one. Now, when you go to x approaches minus infinity, you think, well, it's the same, because if you're just going to take the positive square root of x squared, it's just going to be what? Positive square root of x squared, which equals x, right? You just want the positive one. It doesn't work. Okay, it just doesn't work. So you got to think of this this way. If x approaches minus infinity, then minus x approaches infinity, okay? So what you're going to do, you're going to take the negative square root of x squared. So you're going to do this. All right, so you're going to divide by this in the numerator. Well, in the numerator, you're just going to divide by x. Now, in the denominator, when x approaches infinity, you're going to divide by this. When x approaches minus infinity, it's the same as minus x approaching infinity, so you're going to divide by this stuff. Okay, so let's do this. So it's going to be 3 minus 2 divided by x over. Now you see, when you take the square root and you divide it like the square root of blah 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 divided by the square root of blah blah blah, you can make this whole thing just one square. So that's what we're going to do. Divided by the square root, okay, of, you see, you're gonna, okay, it's because I don't want you guys to be confused. What I'm gonna do is this way. Square root of 2x squared plus 1 divided by the square root of x squared. Okay, so this equals this thing divided by the square root. So you can just consider this whole thing one big square root. So that's what I'm going to do. I'm going to drop the square root all the way down here. Okay, maybe draw it a little bit more beautiful like that. And then you have 2x squared plus 1 divided by x squared. Yeah. All right. Now, yeah, if you want to do it like this, divide this by x squared, and you're dividing this by x squared. Okay? All right, now you got 3. This thing here goes to 0 as it approaches infinity. It goes to 0 from the right side. Why? Because from the right side, this x is going to be positive. So 2 divided by a positive, well, actually, I'm sorry. This x is going to approach positive infinity. So positive divided by positive is positive, and with the negative here it becomes a negative. So this is going to be like 3 minus 0.000001. Okay, so the whole thing in here is going to be positive in the numerator. So, okay, 3 minus something that approaches 0. What about when x approaches negative infinity? When x approaches negative infinity, so this 2 divided by negative infinity is going to be a very small number that's positive. I mean, that's negative. And with this negative, the whole thing is going to become a positive. So it's going to be like 3 plus 0.00000, infinite zeros here, and a 1. So it's also negligible, okay? Doesn't matter what you do, the numerator is going to approach 3. Divided by, now let's consider the positive thing. X is approaching infinity. So what you do is that you're going to do 2 here, okay? Well, square root of 2. Square root of 2. And then you have this thing here canceling with this one, right? Plus this one is going to approach 0, and there you go. That's the limit, okay? When x approaches infinity. Now when x approaches minus infinity, so I'm just going to copy this thing. No, I can't do that. No, I can't. It's not going to work. I'm going to do the whole thing in the bottom here again. 3 minus 2 divided by x. The whole thing. And now you're going to divide by the negative. So you see you're going to have a big square root in here. And we had 2x squared plus 1. But because you're dividing by the negative square root of 2, square root of x squared, you put the x squared in here. Okay, hold on. You put the x squared in here and in here, but you bring the negative outside the square root, or outside the root, okay, even if it's any kind of even root. So this is going to approach 0. Okay, so we're going to have a 3 here divided by, here these two are going to cancel out, and this one's going to approach 0, so you have negative, oh guys, I'm just going to put this here, so equals, so negative, the negative I'm going to put here, square root of 2, okay, and that's what happens. I'm going to show you guys the graph now. So you have 3 divided by the square root of 2 and minus 3 divided by the square root of 2. And that's what it looks like. So you got a horizontal asymptote in here. There's going to be 3 divided by the square root of 2. And the bottom one will be 3 divided by the minus square root of 2. That's it. It's approaching infinity here. It keeps going. Sorry. Keeps going here. And it keeps going over there, but without crossing the blue line. Okay. Now, okay. Man, sine of x. Okay, as x approaches infinity, well, it's just gonna oscillate between 1 and minus 1, right? It'll be like this. So it doesn't have a limit. Okay, what's the limit? It doesn't have a limit because it oscillates. What about sine of x divided by x? We saw that as x approaches 0, this approaches 1. Okay, by the sandwich theorem, That was the beginning of the calculus course. But what about as x approaches infinity? Well, I know that this is going to approach 0. Why? Because the sign of x is between 1 and minus 1, 1 and minus 1, and x is being infinity. Okay, so you got maximum 1 or a minus 1 or something in between divided by something huge. So this is just going to approach 0. But there's another way of looking at this. I'm going to bring this over here. And look at that. We know that the sign of x is between 1 and minus 1. So greater or equal to minus 1. And it's less than or equal to 1. Okay? Now, if you divide this by x, you got to divide this by x and you got to divide this by x. Now, as x approaches infinity, this is going to go to 0. This is going to go to 0. And by the sandwich theorem, this has to go to 0 too. I'm going to show you the graph. There. Okay. So the function in the middle here, the first graph, the black graph, is sin of x divided by x. The top one is 1 divided by x, and the bottom one is minus 1 divided by x. And you can see that sin of x divided by x is sandwiched between the other two functions. Okay. Let's keep going. The limit of x cubed as x approaches infinity is just going to be infinity, because you have infinity times infinity times infinity. X cubed as x approaches minus infinity. It'll be minus infinity, because minus infinity times minus infinity, that's going to be plus infinity, times minus infinity, negative infinity. So now this is something nice. Okay, here we go. Yeah, I like this. I just like it. There are some things in math that I like more than others. You know, some topics that I like more. You got this divided by x plus 1. All right, so we know, because of the previous videos, for anybody that's been following me, that this is going to approach infinity. Why? Because the numerator has the largest power than the denominator. The denominator has a power of 1, the largest power is 1, and the numerator is the largest power is 2. So we know that as x approaches infinity, now here we go. As x approaches infinity, okay, this is going to be positive. This doesn't matter because it's a small number compared to x squared. So this is going to be positive, and the x in here is going to be positive. So positive divided by positive, that means that y will approach infinity. Okay, now what about when it's negative infinity? X approaching negative infinity. So this is going to be positive because it's squared, and this is going to be negative because it's to the power of x is elevated to a naught power. So positive divided by negative, y will approach negative. Fine, you know, that's great. But there's something more interesting here. You see, when you make long division, so this has already been determined. Okay, I'm just gonna drag this down here, and then here's what I'm gonna do. Okay, I'm gonna get this thing out of here, and this, and this. So it's being divided. We're gonna make, sorry about that, I have a flu or something. So divided by x plus 1, but I'm gonna make long division. Okay, so anybody that doesn't know how to make long division, I'm gonna walk you guys through this once. So you got a 2x squared here and you got an x. How do you make this x 2x squared? You do this. Okay, so 2x times x, and when you come over here, you gotta invert the sign. So you go like minus 2x squared. It's just like the division, regular division. And here you have 2x times plus 1, that's 2x, but you come here with a negative sign, minus 2x. When you add these two cancel out, and you got a minus 6x. That's the remainder, okay? So you can say that 2x squared minus 4x divided by x plus 1 equals, now here we go, 2x plus, as a matter of fact, it's a minus 6x divided by x plus 1. Well, let me think. No, we can keep going. Sorry, I stopped too early. I stopped too soon. Okay, so you got a negative 6 in here, right? And then you put negative 6. Yeah, because I stopped too soon. So negative 6 times x, negative 6, but it comes over here positive 6x. And then negative 6 comes here with a 6. Okay. So these two cancel out, and you have a 6. Okay, now we go. So 2x squared minus 4x divided by x plus 1 equals 2x minus 6, okay, plus 6 divided by x plus 1. For people that don't understand, you get the remainder and you divide it by the quotient, okay? So you can visualize easily what I'm doing here. Look at this, 9 divided by 5. Everybody knows 1, right? I'm going to make it exactly the same so you guys see the similarity. That's 5 coming over here, minus 5, so you have a 4. This is the remainder. So 9 divided by 5 equals 1 plus 4. You get the remainder and you divide it by this. Okay, divided by I think it's the divisor, yeah. 4 divided by 5. Now, does this make any sense? Well, let's see. Let's put the minimum common denominator here. So if I'm multiplying this denominator by 5, I gotta create a 5 in here too. So 1 times 5 is 5. Okay. 5 plus 4 is 9 divided by 5. So you see that this is the same as this. All right, so now you understand what I've done here. Now look at this. Why did I do this? Well, we know that this is going to approach infinity, okay? So when you plug infinity into x, you're going to have here 2 times infinity. Oh yeah, that's infinity. But let's not look at the limit. Let's not look at the limit. Let's forget about the limit for a second and think about the graph. So what is this going to approach as x approaches infinity? Okay, well, the equation that this is going to approach is 2x minus 6. Now, as x approaches infinity, this denominator becomes so large that 6 divided by infinity is nothing, okay? So this goes to 0. What am I trying to say? Is that as x approaches infinity, okay, this function here approaches this. Now, what is that? 2x minus 6 is a straight line, okay? Look at this. Oh yeah, there's something else too that I wanna. And it doesn't matter if it's x approaching infinity or negative infinity. X approaching negative infinity. Okay, you're gonna have negative infinity here, and this is gonna be so large that's just gonna approach 0. So it doesn't matter if x approaches infinity or negative infinity. This equation is going to approach 2x minus 6. All right. Now, of course, since it's going to approach 2x minus 6, so it's going to be 2 times minus infinity minus 6. All this is a negative number. So we know that when x approaches infinity, y will go to positive infinity. Yeah, we've seen this here already. Okay, I'm just trying to link up these two information. I'm trying to connect the dots. And when x approaches negative infinity, then y is going to approach negative infinity. Okay, now I'm going to show you guys the graph. See here, the blue line is 2x minus 6, okay? It's not part of the formula, it's not part of the original formula. The original function is 2x minus 4, 2x squared minus 4x divided by x plus 1. So the graph of this function is going to be these black curves in here, these black lines. But then you see, as x goes to the right infinitely, y goes up infinitely, getting closer and closer to the blue line, which indicates 2x minus 6. And as x approaches negative infinity, y is going to go down infinitely, and it'll always approach the same line, 2x minus 6. I think this is cool. Okay. Let's have another example of this. So x squared minus 2x plus 4 divided by x minus 2. So we know, okay, x minus 2, we know this is going to approach infinity. All right. And okay, so when x approaches infinity, y will approach infinity, because positive, positive, fine. When x approaches negative infinity, y will approach negative infinity, because it'll be positive in the numerator and negative in the denominator. I find it hard to say this sequence of words, negative in the denominator. Okay, now I'm going to make long division. So x minus 2, I'm going to erase this here. I don't think you have to worry about this bar here. Okay, so let's go. X squared, no, just x. So 2x squared, nothing. Minus 2x plus 2x, it's nothing here. Okay, and then you have a 4. Now getting this 4, can you do anything here? No, you can't. Because if you put anything here, let's say plus or minus, doesn't matter. Okay. 4 is going to be 4x. You don't have a 4x in here, so you can't do anything. It's over. All right, so we can conclude that x squared minus 2x plus 4 divided by x minus 2 equals x plus 4 divided by x minus 2. Okay, now as x approaches infinity or negative infinity, this is going to go to 0. What do you have? You have x. That means that x is also a straight line. Okay, it's the straight line y equals x that goes through the origin. And that means that this equation is going to approach this equation. And we'll see that now. Okay, see, you got a slant asymptote in here, which is x equals y equals x. Well, okay, and you have the graph in here getting close to it. You also got another asymptote at x equals 2, because if x equals 2, yeah, that's kind of weird. Yeah. Okay, so x equals 2 is going to be a 4 here, plus a 4, 8, minus 4, 4, divided by 0. So it doesn't exist. So you got a vertical asymptote and a slant asymptote. See? There you go. The blue lines in here. I know it's kind of fainted, but you know, it's the best I can do. Okay, now yum yum yum. All right, I'm just gonna make one exercise in here. All right, here we go. I'm gonna show you guys something. You got this box, right? The box doesn't have a lid. It's got a base, right? So it has a bottom, and it has the 4 sides, but it doesn't have a lid. Now you got a problem that says a manufacturer wants to design an open box, having a square base and a surface area of 108 square inches, as shown in figure 3.53. That's the figure that you guys are seeing. What dimensions will produce a box with a maximum volume? Okay, so this is an application of differentiation. So we're going to see here, what is the volume? The volume is going to be the area of the base, which is x squared, okay, because the base is a square. It looks like a rectangle here, but it's not. So the area of the base is x squared times the height. X squared times the height. Fine. What is the surface area? The surface area, okay, is going to be the area of the base, which is x squared, plus you got the 4 sides, okay, so it'll be 4x times h. And there's something else too. Yeah, the surface area, the problem wants this is forcing, it wants it to be 108 inches. It wants it to be, okay? So how do you do this? You can create a bunch of boxes with different volumes, okay, and with the same surface area. Now, which one is gonna, what kind of dimensions for x and h is still gonna respect the surface area of 108 inches, but it's gonna increase the volume. What's gonna happen, guys, is that we're gonna find a formula that does this, okay? This is gonna be like a value for x, and this is gonna be a value for the volume. So we have something like that. Volume cannot be negative, okay? So we're gonna have something like that. Well, volume can never be 0 either, so it approaches 0. So it'll have it'll be kind of something like this. I don't know exactly, okay? So at some optimal value of x in here, you're gonna have the maximum volume. Now, how do you do this? Well, you find the function of this graph and you differentiate it, and then you're gonna have, you differentiate it and you equate it to 0, because then you know where the tangent's gonna be, the local and global, in this case, maximum, okay? So how do we do that? Well, we got to derive the volume here with respect to x. That means that we got to get rid of this h, okay? Now, what is h? H equals 108, right, minus x squared divided by 4x. Yeah. This is h. Now, we got to multiply. You see this h in here, we're going to throw it over here, right? We're going to replace it in there. So the volume is going to be multiplying this to x squared, 108 x squared minus x to the 4th divided by 4x. Dividing everything by x, because you got x everywhere. So you get this x out. X squared divided by x is just x. X to the 4th divided by x is x cubed. Okay, there you go. Now you want to differentiate this. Well, you want to differentiate this stuff with respect to x. Okay, that's what we're going to do. So I'm going to get this notation here out, and I'm going to keep doing it. Oh, okay, dv dx, right? The 1/4 is just a constant. I'm going to keep it in here. So 1/4 times 108 minus 3x squared. Okay. Well, let me think here. dh 108 minus x squared divided by 4x. And then you multiply that, so you got an x squared minus x to the fourth over 4x. And you have I'm just thinking here, thinking out loud. I don't know if I'm making a mistake here. Anyway, so let's see. When you differentiate with respect to x, you got this. So 108 minus 3x squared. Okay. I'm just gonna put the 4 here because it was no good to get it out. It was no good to get it out. And I'm just gonna scratch this. Now you want this to be 0, okay? Now let's see if this is gonna work. If this is to be 0, you can just multiply, cross multiply. So this is gonna be 0, forget about this 4, okay? And then you have 3x squared equals to 108. Then you have x squared equals to 36x equals to plus or minus 6. Now, minus 6, no, you can have a minus width and a minus length. Okay, so forget about the minus, you just got a 6. So there you go. 6 is when you're going to have the maximum volume. Okay, now, look, V is going to be equal to 36 times H. What's going to be the value of H? Well, let's use this formula. I know it's a mess in here, but it's because I wasted enough time already. So this is going to be 36 plus 4 times 6, 24. H equals 108. All right. Now that means that H equals 3. Okay, because 108 minus 36 equals 72. 72 divided by 24 is 3. So you multiply this by a 3. And you get 108. It's actually a coincidence. 108 cubic inches. Okay, because everything is in inch, so the volume is going to be that. So that's the maximum volume. Okay, you're gonna have a square a square base box because the base is squared, where the surface area and the volume are the same. The surface area is 180 square inches. I'm sorry, I forgot to put the square inches here. And the volume is going to be 108 cubic inches. If I'm not making any mistakes. I don't think I made any mistakes, guys. I'm going to go to the next video now. Because the next example is kind of the same, but that's it. All we gotta do is get two functions, and we're gonna replace one of the functions into the other, so that the function is just gonna have one independent variable instead of two independent variables. We're gonna differentiate with respect to that variable and find a minimum or a maximum. All right. Okay.